What if the story of our universe, the one we've all been told for decades, was wrong? The James Webb Space Telescope, humanity's most powerful eye on the cosmos, peered into the dawn of time and found something that, well, something that shouldn't exist according to our neat and tidy theories. It's found galaxies so massive and surprisingly advanced they defy our models of how the universe began. This isn't just a minor puzzle piece that doesn't fit. This is the story of a discovery that's forcing us to rethink the cosmic creation story itself. For over half a century, the story of creation was pretty much settled. It's called the Big Bang. The theory says that about 13.8 billion years ago, everything, all of space and time, was crushed into an impossibly hot, dense point. And then it started expanding. This wasn't an explosion in space, but the expansion of space itself. As it stretched, it cooled. For the first 380,000 years, the universe was just an opaque, glowing fog of plasma. Eventually, it cooled enough for the very first atoms to form, almost entirely hydrogen and helium. From that simple start, complexity was supposed to be a slow cooker recipe. Our standard cosmic rulebook, known as the Lambda CDM model, predicted that gravity would slowly, patiently pull the first gases into little clumps. These clumps would light up as the first stars. Over hundreds of millions, even billions of years, these small proto-galaxies would drift and merge, like tiny streams flowing into a small river, which then joins others to create a mighty one. And this model has been stunningly successful. It explains the universe's expansion, the leftover heat from creation we can still measure, the cosmic microwave background, and the vast web-like structure of the cosmos we see today. Scientists were confident that when we finally got a telescope strong enough to see the cosmic dawn, we'd find exactly what the model promised. Small, messy, chaotic baby galaxies just getting started. But that's not quite what Webb found. Welcome to Cosmic Chronicles. We have noticed that 91% of you that watch this channel frequently do not subscribe. If you've ever enjoyed my video, please could you do me a favor and hit the subscribe button. It helps this channel more than you know, and the bigger the channel gets, the more valuable content you enjoy. The James Webb Space Telescope. Launched in late 2021, its giant golden mirror was built to do something truly special: look back in time. It does this by capturing infrared light. As the universe expands, light traveling across it gets stretched, shifting its wavelength toward the red end of the spectrum, a phenomenon called redshift. It's like how the pitch of an ambulance siren drops as it speeds away. The more distant something is, the more its light is redshifted, and the deeper into the past we're seeing it. Webb was designed to find the very first galaxies, to witness the universe in its infancy. In programs like the jwst Advanced Deep Extragalactic Survey, JADES, it stared at tiny patches of black sky for hours, gathering the faintest, most ancient light imaginable. It looked back to a time just 300 to 500 million years after the Big Bang. That's peering across more than 13 billion years of history. And it found galaxies. But they weren't the small, clumpy proto-galaxies our theories had promised. Instead, Webb saw what some astronomers called universe breakers. These were galaxies that were shockingly massive and luminous for their age. One of the most distant ever confirmed, JADE GSZ 14-0, existed less than 300 million years after the Big Bang, yet it was already dazzlingly bright with an estimated mass of hundreds of millions of suns. These weren't cosmic infants. It was like looking into the universe's nursery and finding a toddler who already weighs 200 pounds. Scientists were floored. Spectroscopic analysis suggested some of these galaxies contained dust and heavier elements like oxygen. Now, these elements are forged in stars and scattered when they die, but that process takes time. The issue isn't that it requires billions of years. Massive stars live fast and die young, enriching their surroundings in just millions of years. The tension was in how efficiently it happened. These galaxies looked mature. They looked impossible. It was the kind of discovery that doesn't just ask for a small tweak to the model, but shakes its very assumptions. The discovery sent ripples of excitement and confusion through the astronomical community. The paradox was all about time. According to our trusted cosmic models, the universe just wasn't old enough to build these giants so quickly. There shouldn't have been enough time for that much matter to gather so effectively. So how do you explain it? The data sparked a firestorm of ideas. The most dramatic one was that our timeline is wrong. A few papers proposed that if these galaxies had more time to form, then maybe the universe is much older, perhaps as old as 26.7 billion years. This idea, however, is a fringe theory that clashes with the overwhelming evidence for the 13.8 billion year age from things like the cosmic microwave background. The mystery only got weirder as Webb kept looking. It spotted a whole population of strange objects nicknamed little red dots. These were extremely compact, reddish objects from the early universe. The leading theory is that many of them are powered by ravenous, growing, supermassive black holes at their centers, something that's tough to explain so early in time. JWST also found candidates for massive galaxies that seem to have already stopped forming stars, becoming quiescent or dead when the universe was just a toddler. While it wasn't true that everywhere Webb looked it found anomalies, the most extreme examples were posing a serious question. Had humanity's greatest telescope just broken our most fundamental theory of the universe? This is where the story gets really interesting. While some headlines declared the Big Bang dead, the vast majority of scientists weren't tearing up their textbooks. Why? Because the core pillars of the Big Bang theory are stronger than ever. The evidence for an expanding universe is undeniable. The afterglow of creation, the cosmic microwave background, has been mapped in stunning detail and matches the theory's predictions incredibly well. The amount of the lightest elements in the cosmos is exactly what Big Bang models calculate. The James Webb discoveries don't contradict these foundational truths. So, if the Big Bang itself isn't broken, what is? The answer is more subtle and honestly more exciting. What's being challenged aren't the pillars of the theory, but our specific models of what happened after it. The problem isn't the cookbook, it's our recipe for one particular dish: how to form a galaxy. The impossible galaxies don't mean the universe is older. They mean that galaxies somehow grew up much, much faster and more efficiently than we ever predicted. That 200-pound toddler wasn't secretly an adult. It just grew at a shocking, unprecedented rate. Our old models assumed a slow and steady growth. Webb's data suggests the early universe wasn't a patient construction site. It was a chaotic, rapid-fire boomtown. Star formation might have been way more explosive, gas may have collapsed into stars more directly, and maybe supermassive black holes were born from massive seeds instead of growing slowly from smaller ones. In other words, Webb hasn't shown that the Big Bang is wrong. It has shown us that our understanding of its aftermath was far too simple. The James Webb Space Telescope was built to answer our oldest questions. But the greatest scientific discoveries don't always give us the answers we expect. Sometimes, they show us we weren't even asking the right questions. The existence of these impossibly massive early galaxies hasn't broken the Big Bang. Instead, it has shattered our simple models of cosmic evolution. It's thrown open the doors to a new, more complex, and frankly, far more interesting early universe. One that was able to build huge, luminous structures in a fraction of the time we thought possible. We are now faced with a profound and thrilling mystery. How did the universe build these cosmic giants so quickly? What physics was at play in that primordial furnace that our theories completely missed? JWST hasn't given us the final page of our cosmic story. It has just revealed that the first chapter is a wilder, more spectacular tale than we ever imagined. and the quest to understand it has only just begun. The universe is proving to be stranger and more wonderful than we ever dared to think. If you want to stay on the front lines of this cosmic revolution and explore the answers as scientists uncover them, make sure to subscribe for more deep dives into the mysteries of our cosmos. And let us know in the comments, what do you think is the most mind-blowing discovery from the James Webb Telescope so far? Thanks for watching.